Here's our first example of how to solve physics problems in one-dimensional motion. So here's a simple problem. Let's say we have a car. It's driving a distance of 1,400 meters in a time of 25 seconds. It starts out at zero velocity and it has a constant acceleration. How fast will it be traveling when it gets at the end of those 14 meters? Did I say 14? I meant 1,400. All right, the first thing you want to do is draw or write down your three equations of kinematics. So let's do that. So if you haven't already done so, you should memorize those three equations. First equation, V equals V sub naught plus AT. Second equation, X equals X sub naught plus V sub naught T plus 1/2 AT squared. Third equation, V squared equals V sub naught squared plus 2A times delta X. All right, those are the three equations. Now remember that the V, the X, and the V squared, those are the velocity typically at the end of the event. So that would be the final velocity. We don't write sub F, but we really do mean sub F. Now, which of those three equations do you need? Well, let's see what we've given. We're given that the time is 25 seconds. We're given the total distance. So time and distance are known, which means I probably don't want to use the third equation because we don't use time there. And since time is given, we probably want to use it. So we probably want to use one of these two equations, maybe even both. All right, so we're not going to use the third equation. Okay, so what is not known? Well, we don't know the acceleration. A is not known, so even though they don't specifically ask for it, it's not a known quantity. And the fact that they tell us that it's constant just means that we're able to use those three equations of kinematics. All right, so it means we need to find two things, velocity and acceleration, which means we probably need to use two equations and use them simultaneously. All right, so what I can do is, since X is known, so this is known, the initial distance is 0, the initial velocity is 0, so I can take this equation and write it as X equals 1/2 AT squared. Since I know X and since I know T, I can use that equation to solve for the acceleration. Then I can plug that acceleration into the second equation to find the final velocity. So that's my strategy. So first I'm going to solve this for A. So we have 2x equals AT squared, or A is equal to 2x divided by T squared. In this case, it's 2 times 1,400 meters divided by the time, which is 25 seconds squared. All right, now I need to find my calculator. Here it is. Never have your calculator too far away. So that's 2,800 divided by 25 squared equals, and let's do that again. 2,800 divided by 625 equals, yep. So the acceleration is equal to 4.48 meters per second squared. All right, now that we know that, we're going to take that and plug that into the acceleration of that equation right there. Okay, so now we take our other equation, kinematics. V is equal to V sub naught plus AT. Remember that the initial velocity was equal to 0, so that goes to 0. That means the velocity is equal to the acceleration, which is 4.48 meters per second squared times a time of 25 seconds. And notice that, let's see here, 25 times that times 25 equals, that would be 112 meters per second. Now that's really fast. So this is not your typical stock car that you buy in the local car dealer. This is probably a race car, but nevertheless, there are your answers. Final velocity, 112 meters per second. Acceleration, 4.48 meters per second squared. So again, strategy-wise, you write down everything that's given. You write down the three equations of kinematics. You determine which one you're going to use. Typically, that depends upon whether or not time is known. If time is known, you probably don't want to use that one. If time is not known, you probably want to use that one for sure. So we decided that the two other ones were candidates because they both had time in them. Then you looked and see what else was known. Since distance was known, you could decide that, I'm going to use this equation first to solve the only unknown in that equation, which was acceleration, which we then plug into the other equation to find velocity. And that's how we do that.